This is the answers to the homework pages 427 and 428, Unit 12, Lesson 5. Number 1, yes, they are independent. The outcome of the second flip had not been affected by the first flip. B, no, they are not independent because the first child was not replaced. Number 2, you're to omit. Number 3, A, the probability of S is 1/4. B, the probability of S given E is 1/4. And yes, they are independent. C, the probability of S given M is 1/2. And does the probability of S given M equal the probability of S? No, 1/2 does not equal 1/4. So no, they are not independent. Number 4 is choice 2. Number 5, no, the two events are not independent. 0.14, does that equal 0.0612? No. Number 6A, no, they are not independent. And these are the two decimal. If you used the probability of G and R, does that equal the probability of G times the probability of R? If you use one of the givens, right? If you use independent probability of red hair given green eyes, does that equal probability of red hair? This is what you end up with. 0.6, does that equal 0.18? No. And or if you use probability of green eyes given red hair, does that equal probability of green eyes? These two decimals are not equal. So any one of those three ways. B, they are very close to decimals, but no, right? Again, you've got the three different ways worked out here. Probability of blonde hair and brown eyes, does that equal probability of blonde hair times probability of brown eyes? No, 0.13 does not equal 0.1295. If you round, they would be equal, but if we're not rounding, no, they're not equal, so they're not independent. And then here, probability of blonde hair given brown eyes, does it equal probability of blonde hair? Same thing, decimals are very close, but not exact, or the other way. You get these two, very close, but not exact. Number 7, no, they are not independent. It did not show the other the other two ways. And the same with number 8, no, they are not independent. So going back to any explanations, I guess number 3, probability of perfect square. Perfect squares are 1/4, and so that would be 2 out of the total possible 8 outcomes, which reduces to 1/4. Probability of S given E, that's going to be probability of even is the denominator, which there are 4 numbers that are even, and probability of perfect square and even, there's just the number 4, that's the perfect square and even. So that's 1 out of 4. And they're independent if the probability of S given E equals probability of S. And 1/4 equals 1/4. So yes, they are independent. C, the probability of S given M. M stands for a multiple of 4. So that would be 4 and 8. So the denominator are those two possible. And the numerator is perfect square and multiple of 4, which is only that number 4, which would be 1. So 1 out of 2 is the probability of S given M. And does the probability of S given M equal the probability of S? Probability of S was 1/4. 1/2 does not equal 1/4, so no, they are not independent. If two events A and B are independent, then the probability of A and B equals the probability of A times the probability of B. That's a formula or a definition. You should know that. Number 5, it said to use the product test, so meaning is the probability of smoker and asthma equal the probability of smoker times probability of asthma. So smoker and asthma was the 0.14. Smoker is 0.34 and asthma was 0.18. 0.34 times 0.18 is 0.0612, which does not equal 0.14. So no, the two events are not independent. Number 6a, I tried to run through the two. All right, so, or the three different ways. Does probability of green eyes and red hair equal probability of green eyes times probability of red hair? If so, then they are independent. So green eyes and red hair. Green eyes and red hair is 0.15. Does that equal probability of green eyes is 0.25 and the probability of red hair is 0.18? No, that product is 0.045, which does not equal 0.15. Or for 6a, you could have went independent if probability of red hair given green eyes equals probability of red hair. So red hair given green eyes, so we're looking at our green eyes total denominator 0.25, and of those red hair is 0.15. So 0.15 divided by 0.25 is 0.6, and probability of red hair is simply 0.18. No, those are not equal, so they're not independent. Or independent if the probability of green eyes given red hair equals probability of green eyes. So again, you can use any one of these three. You don't have to show all three. Any one of these three would be correct in answering the question 6a. Green eyes given red hair, so given red hair 0.18, that's the denominator. Green eyes is 0.15, divided by 0.18 is 0.83, the 3 repeats, and probability of green eyes was 0.25, so no, they're not equal. And then B, any one of those three. Number 7, the probability of snows. The independent if the probability of snows and rains is equal to probability of snow times probability of rain. So snows has to be this whole thing, which is 8 out of 31. So probability of snow is 8 out of 31. Probability of rain would be the 13 out of 31. And snow and rain is the overlapping, the 5 out of 31. Looking at these as decimals, 5 over 31 is 0.16, approximately 0.16, and 8 over 31 times 13 over 31, approximately 0.11. So no, they are not equal, so they're not independent. And then similarly for number 8, you first had to complete the table. Are the events participates in extracurricular activities? And know what I want to do after high school, independent or not independent. Justify your answer. And again, I only showed one of the 3 ways here. Okay. So first completing the table. And I use K for knows what they want to do after high school, and not K for not knowing, and P for participates, and not P for not participating. So 550 plus 50 gives you the 600. 600 plus 400 gives us the 1,000. And then 550 plus 250 will give us the 800. This would be 200, and 50 plus 150 gives us the 200. Or 250 plus the 150 will get us to 400. So probability of participates and knows what they want to do after high school. Does that equal probability of participates times probability of knows? So P and K is the 550 over 1,000, or 0.550. Does that equal probability of P, which is 600 over 1,000, 0.600, times the probability of K. K is 800 over 1,000, 0.8. So 0.6 times 0.8 is 0.480, which does not equal 0.550.